Hi, this is Nilay from Kamu. In this video, I want to present a new approach for connecting AI agents to factual real-time data that Kamu have developed in collaboration with Brian. Brian team is building a powerful AI agent for DeFi that can automate Web3 transactions using natural language. But much like in traditional finance, knowing what transactions to ask the agent to do is a tricky part. Finding good insights and trading strategies in DeFi requires analyzing increasingly large amounts of data. Working with factual data remains a significant weak point for LLMs. For example, let's say we want to stake some crypto. So we will ask ChatGPT, what are the top 5 DeFi pools on Polygon by annual percentage yield? We get an answer that ranks some pool names, but doesn't look too convincing. It doesn't even include the APY metric that we asked for. Language models are very good at generalizing information they are trained on. But if you want it to recall facts, the generalized knowledge will result in what we call the hallucination, or making up facts that might sound plausible but are incorrect. These models also take months to retrain, so incorporating real-time information the world produces every second is not practical. This is why most LLM agents today use RAGs, Retrieval-Augmented Generation. In RAG technique, a model is paired with a vector database that finds the most relevant information to the user's question and pass it to the model to generate a more informed response. But this approach has many limitations too. In our example, the response links to several articles and videos as the RAG sources. But if we look closer, they include a blog article that is 4 years old. So not only we get data from a stale and potentially non-credible source, we also have to trust the LLM operator to decide which sources are included in RAG and which aren't. The company that operates RAGs is in full control of what data you actually see. LLM companies are building massive proprietary data collection systems that don't offer any transparency. We propose a new approach called Oracle-Augmented Generation that connects AI agents to verifiable sources of structured data. Let's open the Brian AI agent interface and ask the same question. What are the top 5 DeFi pools on Polygon by APY? We just got a concise ranked answer based on factual real-time data. The numbers we see here are not coming from blog articles that you cannot verify. They are based on data from multiple independent providers or even sourced directly from blockchain nodes that are integrated through Kamu's decentralized data fabric in a completely transparent process. The process goes like this. Brian's agent queries Kamu node to find the most relevant datasets that can answer the question. Kamu's response includes a bunch of metadata about each dataset, like schemas, README files, and most popular user queries. LLMs can then use this information to generate an accurate SQL query. The query is executed immediately, and LLM is asked to interpret the query result to the user and can display it as text, graph, or a map. So instead of interpreting random articles on the web, the agent generates an SQL code to data mine the answer in real time. What differentiates our approach from regular text-to-SQL agents you might have seen is the verifiability mechanism hidden behind this single hyperlink. Every agent response based on Oracle's data is accompanied by a cryptographic proof of the query. The link takes us to a Kamu node that shows a decoded proof. The proof includes exactly which SQL query was executed, what datasets and what snapshots of their state were used in the computation. We can also see the result data that was reproduced identically to the past query and the validation status of the proof that ties the response to a group of nodes that executed the query. While in RAG, the model has to infer the answer directly from unstructured context data. In Oracle-Augmented Generation, the model generates query code and delegates the execution to an analytical system. This not only allows it to work with much larger volumes of data, but also significantly decreases the likelihood of hallucinating because all computations are performed deterministically. Our approach offers auditability and provenance. Even if the answer requires processing terabytes of data, the generated query can be easily inspected and understood. Similarly, we can see if the query is using reliable data sources too. Secondly, we get accountability. Succinct cryptographic proofs can be cheaply stored alongside the chat history of agent responses, allowing user to hold every party that influenced the result forever accountable for its validity, and exposing any attempts to alter or withhold data. When paired with Kamu, this technique can for the first time offer full data supply chain transparency. Kamu takes verifiability a few steps further, extending it from a single query to an entire decentralized network of stream processing pipelines. In such pipelines, raw source data shared by publishers or directly from blockchains can be processed by third parties, cleaned and combined into higher-order, more useful datasets. AI agents will naturally prefer to work with such clean data when mining for answers. But thanks to Kamu, the proof of a single query will automatically include provenance proofs of the entire supply chain, no matter how many hands the data went through. Let's look at more examples that shows how powerful the pairing of LLMs with an analytical system like Kamu is. When I ask for the current price of Ethereum, I know that the answer will be based on real-time data and not some old article. It also allows very specific point-in-time questions, like getting TVL of Ethereum on a specific date, and time range questions, like volume of USDC transactions between October 10th and 20th. While Brian obviously focuses on DeFi-related datasets in their search, this technique works for any domain. Nothing really stops us from asking what is the average land price in Vancouver, and get an answer based on some community datasets. Every new dataset added to Kamu network expands the range of questions that AI agent can answer, and does so transparently without centralization of power. We believe that conversational AI agents will soon become the primary way of how humans interact with data. Perhaps the most important problem in how big AI companies apply RAG today is the economic one. As users might no longer feel the need to open the web pages where RAG sourced the information, those websites start losing their traffic and ad revenue. We may soon see data brokers banning AI agents on their websites. This may in turn make major LLM companies use their virtually bottomless pockets to invest into their own proprietary data pipelines. With legislation around AI and IP rights still unresolved, such degree of centralization would be catastrophic. Oracle-Augmented Generation, in combination with a decentralized system like Kamu, offers a solution to this problem. Through federated querying, it allows AI agents to efficiently combine data from multiple independent sources. Integrated provenance makes answers based on official reputable sources more valuable than unverifiable data from proprietary sources. Verifiable pipelines allow data sourcing, cleaning, and composition to be crowdsourced to a global community that can self-organize into a new generation of data brokers and aggregators. We believe that the verifiable provenance will play a key role in the AI economy. A query proof that tells us where every bit of data came from and who participated in computations is the exact information we need to fairly compensate everyone involved. Provenance provides us a quantifiable way to distribute the revenue upstream to every participant of a data supply chain, starting from data publishers to storage and compute providers, and a global community that builds and maintains the processing pipelines. Thanks for watching. You can find a link to the detailed overview of the protocol in the video's description. Please give Brian AI Agent a try and let us know what you think on Discord.